Hello everyone, this is the project presentation for Group 4. In this project, we'll propose a new app blocker services based on an existing solution called Pi-hole. So the traditional way of installing Pi-hole is to install it on a small devices such as a Raspberry Pi and then put it under a home network. So when the queries generates from a local network, instead of going through the usual DNS, it points to a Pi-hole to filter out some unwanted inquiries, and then only the allowed queries will be forwarded to the upstream DNS service and continue the browsing. And this solution is relatively lightweight and with only less than 300 megabytes of memory, and this is fast and is effective. However, this solution offers no protections outside a particular network. For example, if you switch your mobile phone to a mobile network, you're no longer protected. So for demonstration, this is a summary of a small home network with 9 clients. You can see that about 40% of DNS inquiries were blocked, and the gray part indicates the amount of blocked inquiries in the last 24 hours. And for the top block domains, and the first one comes from a Reddit mobile app, and the second one is from a smartwatch application. And however, with all these block access, and the service remain unaffected. So our proposed solution is to move the Pi-hole to a AWS EC2 with OpenVPN and Pi-hole at the same time. The advantage is this solution is available anywhere and anytime. We can also scale the service easily to anywhere in the world. For connections, the clients either connect to a VPN service which uses this Pi-hole as a DNS server, or the client can use the Pi-hole as a standalone DNS server. Let's look at the performance of different experiments. So we connect to different Pi-hole services and perform a inquiry to about 200 websites across the world. So the first row is a traditional settings. So I access about 200 websites from a home network connecting to a Raspberry Pi. The latency is about 31 milliseconds on average, and the range is from 2 to 184 seconds. However, when I switch to a 5G network and connect the mobile phone back to my home network, the mobile phone is still protected, but you can see the latency almost doubled. So the average goes from 31 milliseconds to 65 milliseconds. The next three rows represents a different Pi-hole services hosted in different EC2 instance, and the performance is fairly similar. If we look at the average latency, it is not as good as the original one, but is certainly better than the second setting. So we conclude that this is a viable option if you wish to protect your mobile devices. So in summary, the traditional setting is easy to set up. It is really fast because of the edge computing. The protection is done locally in a small devices close to our router and broadband router, and versus the cloud service as we proposed. However, this is a single point of failure. When the Raspberry Pi failed, the whole home network fails. And there are also some security and privacy issues. We have seen in the past the hackers can exploit some loopholes in the Raspberry Pi to gain access to the root and then access other computers' files. For Pi-hole on AWS, it is easy to scale. It is available anywhere, anytime. However, the initial setup is a little bit difficult. Um, to use the EC2 instance, even the cheapest one will be a bit overkill because the resources required is really small. And also, when you use the Pi-hole services on WS, you need to either connect it to the VPN or perform some additional DNS settings. So that's the end of our presentation. Thank you.